Okay, let me start late. Bang. Hello, folks. So we're going to talk about closures. There are a few things, and I get to look over my shoulder at these because the screen doesn't work, but people here have used closures. I mean, actually tried to write them on your own. Most people here have at least seen the basics of it. So the basic idea here is to create something that allows us to do a bunch of good things. Not the least of which is get stable values when we need them. You can use them to coordinate between subs. There's a wonderful thing called inversion of control that at least sounds important. And delaying execution, which is one thing I may not have time to get to, but it's one of the biggest uses I've found for this. Also, if you look at we've all seen the new class mechanism that's coming in with 538. It's a type of closure. And what happens is the lexical variables that we saw being the attributes of an object are closed over by the object, just not by a sub. So what we're saying here, generating new objects, passing things in, generating closures around them, is the guts of how the new class mechanism works. So all we're looking at today are subroutines. A closure is a sub. People here are familiar with SubRefs. People have seen how to pass a subref in and out. So all we're looking at is a subroutine that uses a lexical value defined outside of itself. And we get into the second half, I'll get into the first class part of it, which comes from functional programming. When you combine those, you get a really powerful technique for generating reusable code. It's really great for things like parsing and automation. An interesting thing too, this is really ugly on this screen. God, but if you notice, there really aren't that many of them that are green all the way across. And Perl is one of them. So if anyone tells you that you can't write functional code in Perl, the answer is bull. Perl is actually a wonderful language for functional programming. Yeah.
Are you able to enlarge that top row so we know what
No.
we're looking at?
The basic things would be is whether you can pass higher order functions, which means you can get an argument of a sub, or that you can pass a subroutine into a function as an argument. The next is nested functions. Can you have named or anonymous functions defined inside a function, which you can also do now. There are arguments in Perl about whether it's good or bad, but if you're using functional programming, that actually is a really useful technique. And whether you can have non-local variables, closures, and what they call partial applications, which are pieces of things that are cooperating closures that manipulate stuff. The interesting thing is, Perl's green all the way across. Very few, even some of the functional languages don't handle all of these things well. So if you were interested in doing functional programming, Perl's a great way to learn it. So in this case, you have a verbose up on top. You've got a verbose in the middle of a subroutine. Bang! That subroutine is a closure. If I look inside of bar, if I put a breakpoint in the Perl debugger and I get into the middle of bar and I do an $X verbose, I'm going to get undef. The verbose variable is meaningless inside of bar. The only place it has something useful here on the screen is inside of message. Again, if you look at the Perl compiler, lexical variables are snagged off the stack. So basically what happens is that verbose variable, its memory location is interpolated into some code. It's not available in bar. When you're done compiling, that name doesn't mean anything anymore. It's whether or not that subroutine has access to a memory location that the Perl compiler. Perl's not interpreted. It's compiled, folks. When the compiler gets done creating that message sub has a place to put verbose. Bar does not. So this debate has gone on since the beginning of Perl 5. A named sub can be a closure. They aren't just anonymous. It's just in this case, we're closing over something with a named subroutine that's just defined outside of itself. And obvious question, why would you care? One neat thing is, now I've got env of verbose up here, but verbose could have been the dbix call from hell. It could have read some configuration that takes 14 steps to process. I don't know where I got verbose, but wherever I decided to take it from, verbose is fast. It's a lexical variable. It's very quick. If I've got something where I'm parsing data and I read a file and at startup I said, oh, I'm going to be parsing something that's CSV rather than fully tab delimited. I can put a separator in here and have something that's very efficient at parsing the data and doesn't have to figure it out each iteration through a loop because I can set it outside and just run with it. Another nice thing is stable. If anyone here has ever used the system call or forks, we've all seen something where your program uses verbose and you fork something that uses verbose. And somewhere in the code, you're calling a module where somebody sets env of verbose equal to something. And all of a sudden, you've got all this mounds and mounds of log output filling your disk drive. But you don't know where it came from. Because somebody set something that set a reference to env. The nice thing about this is once I've set $verbose, there's nothing can change it. Because there's no code here that can modify that value. So it's a nice way within a module to create stable values that are declared at the top and just don't change. They're not constants. You could actually have a subroutine in here called set verbose or become verbose or quiet that sets verbose to nothing. Peachy. But you're in control of it in this module. And it's not something that's a shared resource that some other module can come in and step on. Another thing that they're nice for is coordination, again, because these are stable and they're lightweight. Whatever I set verbose to at the start, all of these different messages, I know they're going to behave consistently. If I keep using env or verbose, or if I try to make a subroutine call in each of them, even if I use a state variable, I could stick a state variable in each of these, but there's no telling whether or not that value would be stable between each of these different subs instantiating it. Because if we're reading an env and verbose, you get two of these things that do it. Someone over here does a system call. They said env or verbose before it. Well, now half of my code is behaving verbosely and half isn't, and I can control it. Another time that these are nice is if you have something that's defined early. Again, with state variables, I could have an isolated variable, state $start equal time, but I wouldn't set it until the first time I called this runtime sub. That might be too late to give me accurate timing of how long something runs through my program. So if you want a value that is set very early, if you set it, the compilation in Perl is pretty trivial. And at that point, you can get values that are set right at the beginning. You know what they mean. A lot of times that's good for time, processes, system resources, whatever you want. You can isolate things by using a state variable, but then you can't control when the value is instantiated, so you don't always know what it means. The whole point of first-class functions is that I can pass a subroutine out of a function. I can pass a subroutine into something as an argument to it. So at that point, the subroutines become a lot more flexible because I can create them dynamically. So, trivial example, let's say you want to have a counter. And let's say you know that for whatever reason, you can only put a finite number of these in. You want to limit yourself to a certain number of count each time. So I've got an upper limit. You're adding people to a party and you can only have 35 people, whatever. So I generate a counter. I got this function here. You'll see it takes two values in. The second one is big enough that we'll call it infinity for now. It sanity checks things, and then it returns a subroutine. that subroutine has its own private value for the value and final. Each of those values is reinstantiated every time I create this subroutine. So if I create 14 of these counters, they're independent. Now, I could have a single thing where I have my $count equal X and increment it, but then I'd have a shared counter. Everyone would get their own. So with this approach, anybody that needs a counter can get something that goes from whatever number they start with and keeps incrementing by 1 until it hits an upper limit. If the limit's 2 to the 32, most of the time I probably won't run out of it. Does this make sense to people? You can see where this is going. The important thing is, if you call this, the caller gets back a subroutine that was created on the fly. So the trick here again, value and final are private to that subroutine. Every time you come into generate counter, you get new variables. And now I can say something, I can create a 2-digit counter that starts at 10 and goes up to 99, a 3-digit counter. I can generate something that's got 16-bit if I'm loading a database that's got small keys or something. The point is here, I can read something, I get a new 2-digit thing, I get my ID. When I run out, it pukes. Do you see how this works? How many people are awake? Just raise your hand. Everyone with a heartbeat. There we go. So now another use for this, other than just a counter, is reusable code. That everyone has written something kind of like this. Deal with the person hitting a Control-C, deal with hang-ups, say a name or puke, read a line or puke. If we're reading names, it's a password maybe, it's got to be so long, it can't have white space in it, it's got to have some, whatever. We've all seen one like this. And then it works. And so someone says, well, we got to read the path in for the keyboard too. Okay, so you cut and you paste it and you change the word to path. And then you got to read a date. So, okay, so you read a date in and then you... Anyone here who read the Perl Journal, MJD's red flags? If you're cutting and pasting, you're doing it wrong, especially in Perl. The reusable part of this stuff should be reused. You should be creating specific stuff, not cutting and pasting. This isn't Java. So the trick here is, if we look back at this, there's a mixture of boilerplate, interrupt handler, say fails, puke because I can't say something, and specific to what I'm doing right now, the prompt and how I validate it. So let's say I leave the boilerplate. I'm left not knowing what to say and not knowing how to validate it. But let's say now I pass in something that's my prompt and a subroutine, a sanity checker. I don't have to know how or why or what that sanity checker does, but if I run it, it's going to return true or you gave me bad input, period. What just happened? All my boilerplate is now completely reusable. This is called inversion of control because the subroutine that's executing doesn't control the execution. The subroutine passed into it does. So you're not calling a subroutine and saying, here, control yourself. You're calling a subroutine and say, here's the control for you. Another version of this MJD uses in one of his higher class Perl classes was if you're parsing. That might not be a sanity check. That might be a read line splitter that knows whether or not it's splitting on tabs or reading a CSV file where it's got to deal with quotes and all the other mess. You might have a parser that has to know between tabs and commas for the separators, whatever. But you can have pieces of the work that vary. You pass them in as subroutines, and they do their work. And then the framework, that boilerplate, all the sanity checks, stays the same. At that point, I might have code let's say I'm doing dates, I might have this is a date sanity is a closure generator that generates sanity checks for dates. This stuff's obviously pretty trivial because it fits on the screen, but you get the idea. For whatever the value is, if I can parse it, if it's greater than whatever my cutoff is. Now that cutoff could have come from DBI, it could have come from time, it could have come from anything. There could be 15 checks in here for before and after and round it to the nearest minute. I don't care. But all the sanity checks are available to you here, but they're specific to the date check. There's no boilerplate in here. So I can now, all that cut and paste becomes unique. I get a date sanity, I get whatever. I could actually just call date points to date sanity and take the return value and pass it in, but people start to twitch if you get too many levels deep on these things. So, but you see the point here, all of this stuff is unique to whatever it's doing. You're not cutting and pasting any of it. The date sanity and the name sanity might be complete. Name sanity might just be, hey, it has to be non-zero. Date might be 45 checks long. It might have to go to one of these checks might even go to a database. You don't care. Neither does the boilerplate. It just knows things are getting checked. You pass this much in, you get back. Another step for this is I can have a prompt generator. You pass me a prompt and a closure. I pass you something with its own nested closures. It's got one closure of its own for the interrupt handler, and it's got one closure of its own that it makes out of all of this and says, okay, here is something that will prompt people, and it will return you an exception or the valid result. You can take the result of this and pass it into a web generator. These closures can be nested to arbitrary levels. That's where the power of this comes from, is I can daisy chain these, I can stack them, I can combine them, and I can have code that doesn't have to know everything about the top to bottom processing. I can fit it together in pieces that are isolated. And I can encapsulate the logic of each stage without the other ones even having to know why it works that way. Again, I can call this, I call a date, it calls get date. I don't have to know what's going on inside of there. I could pass the get date sub to some other generic thing that just says, hi, I'm going to get the date. You got it for me. Deal with it and keep going. Now, another totally different use of this. We saw a little of that this morning. Everyone's seen how to dispatch something, points to whatever. Foobar is a method. It's looked up at runtime. This is not looked up at compile time. Until the Perl execution hits this line, nobody knows where it's going. Because this is Perl, and I could have installed that subroutine long after this line was compiled. But I can also do this. I can pass a variable whose contents are going to be looked up as the method. One thing people don't notice is I can pass a subroutine reference here. And what basically that bypasses all package lookup. It says I'm going right there. Basically, this technique is how you get private methods in Perl. Because if that subref is lexical, nobody outside the scope of that knows what it is. So I can have a subroutine that generates 15 closures based on select date, select this, validate whatever. And I can call object points to whatever of it, and I'm going to get done what I want to do. I'm not going to bounce around all over. One thing this is really neat for is if you're refactoring code, and you've got something where all of the code, all of the structure of everything is based on a messaging standard, and it changed. And somewhere along the way, you don't want to go in and break all the method chains of everything everywhere. You just need to tweak something. You can put this in and say, okay, if we're dealing or data, if you're reading old files, this can be parse file. And it can say, okay, If it's an older file, a newer file, a later file, whatever it is, put the right parser on the end of it, just go there. The object doesn't know it's being led into La La Land. So again, one thing I use this pretty commonly for is if I get, you're writing something and it's now one screen, it's 2, 3, it's 4 screens, you're starting to get a few too many variables to keep track of, screw it. I can break that whole thing up into a bunch of anonymous subroutines, which may or may not be closures, but this allows me to section the code off. I can isolate the variables. I can break it into reasonable pieces. Now, I might find, oh, I've got a read configuration. Read config returns me something that will read a particular configuration file. I can then generate a method for it. I can dispatch an object into that handler. The object has no idea where it's going. It just ends up in my closure. So again, this is a really nice way to generate safe, dynamic code that doesn't interfere with the objects, but also doesn't get tangled up in the inheritance chain when you need to just be somewhere and get it done. A lot of things I think that people use nested methods for, the nested subroutines. You can do a lot of the same things with these. And anyway, on time. So anyway, a really good description of first-class functions is in Wikipedia, where I ripped that diagram off of. If you really want to see what those columns mean and why they matter, if you just look up first-class functions. The other thing I ripped off a lot of this from was Damian Conway's. Is an excellent class that I don't know if he'll ever give again on functional programming in Perl and Raku. And it shows you how to use folding rather than narration and how all the pieces of Raku fit together to do that. If enough people actually gave a damn, functional programming, and a lot of the stuff with the closures too, because you encapsulate the code, because the pieces of it can be isolated pretty well, it makes the code a lot easier to modify because you're not dealing with side effects. You can't say, oh, we can't take that out of there. Remember, we defined this variable and it cascades into something else. By isolating the effects of things, functional programming reduces the number of variables that are floating around that you have to deal with. And the things like map and grep, where you fold it and you deal with one row at a time, if nothing else, they save you from a whole lot of off by one errors. If people found that interesting, I could probably convince them to let me rip off the class notes, and I could actually do the class next year. If that was something anyone thought was interesting, warn the people who do this, and I can try and teach it. But again, if you look up the closures in Perl, it's one last one because I got 1 minute. If you look up object trampoline, has anyone ever seen that? Yeah, well, I know, but it's a neat problem you get. Let's say you've got an object that is horrifically expensive to construct. You don't want to construct it until you have to use it. I wrote this class when I was writing a call notification system that had a SIP server, a database, a telephone. I mean, there were 8 exterior services I had to poke, and not all of them were always up. So what I did is I took all the things and I made it so if you don't touch the object, it never really tries to connect to the service. And that's the trick with the trampoline object, is until you use it, it's a trampoline object. The first time you call a method on the thing, it becomes whatever object you thought it was, and you never go back to the trampoline again. So you actually have to modify the type of the object over its lifespan. Trivial to do in Perl. Try it in Java sometime. Damien, the other great thing about the module, if you look up object trampoline, it actually manages to break nearly every rule in Perl best practice. Because what it blesses a closure into a hardwired class just as the start of it. It then tweaks the stack, but it just works. Damon Conway loved it. But it's kind of a fun module, and it makes a lot of things where you have to delay construction a lot easier, because you can construct something whenever you want and then just deal with reality when you actually use it.
Yeah, it's a useful enough pattern. I've seen it in 3 different other large Perl firms.
Oh, wow.
They implemented it themselves and they didn't even know.
Actually, if I'd love to see how they did it.
One that was a service that itself was run by XND so that it could unload itself and then reload itself whenever it's called. So it's 2 layers of trampoline.
That's fun. Yeah, I'd like to see how they do it, because I think I've got pretty much the only way that works. The trick is you don't have to have if logic at every step. You just use the thing, and whenever you use it, it becomes what you want it. Anyway, that was the end of the talk. Was that useful?